All right, so welcome to Qual 2. As you can see today, we'll be checking out the cations of iron, aluminum, nickel, zinc, and manganese. So let's take a look at what's going to happen. So the first thing we're going to kind of want to do is separate some of this stuff out because we don't want them all to be in solution at once when we're doing these tests because they're going to conflict with one another. So first thing you'll see is we're going to add some sodium hydroxide, and that's going to precipitate out some stuff with this double line. And then it's going to keep other things in solution. The things that's going to stay in solution are the zinc and the aluminum. So those will stay in solution, and we'll deal with those later. What's going to precipitate out is the manganese, the nickel, and the iron. So once we've decanted, separated them, we're going to redissolve this with some nitric acid. And then we're just going to split the solution into two. These tests won't interfere with one another, so we don't have to worry about whether the stuff is there or not. To one of our solutions, we're going to add this sodium bismuth oxide. And that's going to be our test for our manganese. So when we have some manganese, our Mn2+, and it interacts with this bismuth oxide in acidic conditions, it's going to oxidize the manganese into permanganate. So what we're looking for here is this permanganate, and it's going to be a deep purple color. So check out the video and see if we see this deep purple color. And again, that's testing for the manganese. All right, so I've got my known and my unknown here, and the first thing I'm going to do is add some 6 molar sodium hydroxide until precipitation is complete. So I'll start off with the known. See some precipitate forming. Still definitely forming. Unknown. Precipitate forming slightly different than the known. All right, next up, I'm going to centrifuge and then make sure that all the precipitation is complete. As you can see off screen, I've centrifuged, so I've got my solid approximately on the bottom. Next up, I'm going to add some more sodium hydroxide to ensure precipitation is complete. So you can see essentially no more precipitate is forming. Same story with the unknown. Next up, I'm going to decant, and I want to keep the supernatant for part F. So you see I've labeled test tubes KF and UF. And now the solid in here is actually not very dense, so if I try to pour, it's most likely going to spill over. So what I'm going to do instead is just use a pipette to decant out the supernatant. You can see it's a little tricky. You can see I've disturbed this bottom, And so I'm actually just going to stop decanting here, and we'll just deal with that as the precipitate. Same kind of story here. You're seeing I'm disturbing this precipitate, so I'm just going to say pour a little bit more out, but probably just toss it into the waste. So let me grab a waste test tube. And so we'll just toss out this kind of excess mixture of precipitate and supernatant. Cool. So we'll just trash this test tube. And then for the next step, we'll be working with this precipitate, and we'll save the supernatant for part F. Next up, I'm going to redissolve my precipitate using 6 molar nitric acid and applying heat if necessary. So let's see how this goes. I'm going to add very slowly in the beginning because I've got a basic solution and I'm adding acid to it. Should be more than enough acid, probably too much. Just kind of keep stirring it and let it dissolve. It looks like it's all dissolved away. Repeat with the unknown. So you can see I still have some precipitate left in here. So off screen, I'm going to heat this in a hot water bath for a few minutes. All right, so as you can see here, trying to redissolve this precipitate was actually quite unsuccessful. You can see I've added a large excess of acid, and I had it on the heat for quite a while, but there's still some precipitate remaining. So we're just going to assume that enough dissolved in here that will be okay, and we're just going to keep going and see how it goes. So the next step, I want to transfer about 1/2 ml for part C into each, and then I'll keep the rest for part D, so you can see I've relabeled everything. So let's go ahead and take 1/2 ml each and put them in U containers. And we'll save this for part D. Next up, we're going to confirm that we're still acidic, which we should be, considering how much acid I added. So let's check it out. Oops. Yeah, you can see still acidic. And still acidic. Next up, we're going to add some of this sodium bismuth oxide and see if we see a deep purple color. You can see the lab says to centrifuge, but you can see that you've definitely got a deep purple right away. There's no mistaking that. There's a deep purple there. Let's check out the unknown. And the same thing for the unknown. We've got the deep purple. So we won't centrifuge because we can clearly see the deep purple. All right, so for this next step, we're going to take a look at our other portion of our supernatant here. And to this, we're going to add some ammonium hydroxide. And what this is going to do is going to precipitate out the iron while keeping the nickel in solution, so we can separate the two. And then to this solid portion of iron hydroxide, we're going to reacidify to dissolve the precipitate. And then we're going to add some ammonium thiocyanate. And let's check out what that'll do. So when we combine these two, they'll form this coordination compound, which should have this kind of deep blood red color. So we're looking for this deep blood red color, which will confirm the presence of our iron. All right, so you can see I've got my supernatant from earlier. I've actually just taken a small portion of it to work with. I didn't use all of it because it's kind of an excessive amount of acid that I added. So next up, we're gonna basify the litmus using this concentrated ammonium hydroxide. And this stuff is pretty intense, so I'm doing this in the fume hood. So let's see how this goes. This is the known. Alright, so it looks like my precipitate is now staying, so let's check it with litmus to make sure it's basic. It is kind of turning the paper blue. Let's add a little bit more. So that should be basic enough. We'll just add 2 more drops as per the lab manual instructions. And then repeat with this unknown. You can see that no precipitate is forming. Let's check if it's basic. And then we'll add 2 more drops as per the lab. Actually, it does look kind of like some precipitate is starting to form. Let's add a little bit more ammonium hydroxide, see if that helps. All right, so we do have some amount of precipitate here. Go ahead and centrifuge these 2 solutions and continue on. So you can see off screen I've gone ahead and centrifuged, and now I need to decant and save the supernatant for part E and work with the precipitate. So again, this precipitate is not very dense and so likes to kind of float around, so I'll use pipettes to decant as best I can. So you can see I've gotten to the point where it's hard for me to decant without picking up any of the solids, so I'll get rid of the rest of this liquid, but I'll just kind of toss it away and make sure there's some precipitate that remains. So not perfect, but I've got some precipitate left. I'll save the supernatant for part E. And next up, what we need to do is we need to reacidify these two solutions using some 6 molar hydrochloric acid. That looks pretty good. That looks pretty good. Next up, to my 2 solutions, I'm going to add some ammonium thiocyanate, and we're looking for a deep red color here. And you can see the known, as it should, does go to very deep red. Let's check out the unknown. You can see there's no red color here whatsoever. So, yeah. Next up, we're going to go back to our nickel solution and we'll add some dimethylglyoxime. We'll call that H2DMG. And this will coordinate with the nickel to form a coordination compound. So something like our nickel hexylamine. And this will result in a pink precipitate color. You can take a look in your lab manual to see the exact structure of this. But if we see that pink color, that is confirming the presence of our nickel. So I've got my supernatants from earlier, as you can see. Next up, we're going to add some dimethylglyoxime, DMG, to this solution, and what we're looking here for is a pink red. So you can see our known definitely has it, as it should. Let's check out the unknown. Dang it, I missed the shot, my bad. Either way, you can see this one is pink as well. as you can see, at this point, we're kind of done with this branch of the tree. So we can go all the way back up and take our zinc and aluminum here into consideration. So the first thing we're going to do, kind of move it over here just for space purposes, is to redissolve this precipitate with some nitric acid. And then after that, we're going to add some ammonium hydroxide. What this is going to do is it's going to precipitate out the aluminum as aluminum hydroxide. And then the zinc will stay in solution as a coordination compound with the ammonia. This aluminum hydroxide is a solid, but it's very hard to see. So what we're going to do is we're going to reacidify it. And then we're going to add some more ammonium hydroxide and some of this aluminium reagent. And so that'll reform this gelatinous complex. And then the aluminum ion is just basically a dye that'll stick to this gelatinous complex. And so at the end, what you should see is a nice pink color on our solid. And that'll confirm the presence of our aluminum. All right, so we've got our supernatant from significantly earlier. Next up, what we're going to do is acidify to litmus using 6 molar nitric acid. Not good enough. Still not good enough. Now we're good. Repeat with the unknown. Just make it level, see if that works. Yep, looks good. Next up, we're going to add some ammonium hydroxide until we're basic to litmus, and then 5 more drops after that. basic. And so it's very hard to see, but there is actually a precipitate. If you look closely, you can see it kind of floating around. The camera doesn't quite catch it the best, but there is indeed kind of this gelatinous precipitate in this solution. So it's very hard to see on camera, unfortunately. Maybe this unknown will give us better results. Move it closer, maybe that'll help. Basic enough. Let's just add 5 more drops to each. Next up, I'm gonna go ahead and heat these solutions in my hot water bath, and then I'll also heat up some deionized water as well for several minutes. All right, so off screen, I've gone ahead and centrifuged. Now I'm gonna decant into these and then work with the precipitate. Also off screen, I'm gonna wash this precipitate twice with hot water, 1 ml of hot water each. So I'll decant, wash with precipitate, or wash with water. Precipitate seems to be kind of hanging out on the bottom, so go ahead and just pour the rest in. I'll recentrifuge and then decant this rest of the solution again. All right, so off screen, I've washed and decanted these solutions. So let's continue on. You can still see I still have a good bit of liquid in this one. I wasn't able to decant without really getting rid of most of the solids. So let's try to keep going on and see what happens. The next step is to reacidify using 6 molar nitric acid just until the precipitate kind of disappears. So let's check it out with the known first. So there's still a tiny bit of precipitate remaining, but I don't want to add too much acid, so let's continue on like this. Same thing to the unknown. There's still some precipitate remaining here, but I think enough has dissolved away that we'll be able to get a good indication on our analysis. Let's just keep going on and see what happens. Next up, we're going to add this aluminum reagent. 2 drops in each, I think. Let me double check that real quick. See, it's this kind of red color, so 2 drops in each. And then add some ammonium hydroxide, and we should see kind of a pink-red precipitate form. You can see we've got it's hard to see on the camera, but there's a good bit of pink-red precipitate. And same thing for this one. I'll decant these, that way we can see the color of the precipitate better. All right, so after centrifugation, you can see it's much more clear result. We've got a red precipitate and what is essentially a colorless solution. A little bit of yellow to this one, but don't worry about that. You can see all the red has been adsorbed onto the precipitate. All right, so at this point, all we've got left is to test for our zinc. So we're going to re-acidify with HCl just to get our zinc back as zinc 2+ and along this coordination compound. And then to that, we're going to add this potassium iron cyanide complex. And then if you take a look in your lab manual, that'll form a coordination compound with the zinc, which will give us a nice green color. And this green color confirms the presence of the zinc. And then that's it. We've tested for all 5 of our ions. All right, so I've got my supernanes from earlier. You can see I'm only using part of them. I'm not using all the solution. No point to. We don't want to overflow our test tubes. Next thing we're going to do is we're going to acidify to litmus using 6 molar hydrochloric acid. See, not good enough. acidic. The same thing to the known. Equalize it in volume, should be good enough. Nope, not good enough. Cool. And acidic. You may have noticed that I kind of flopped these two. It doesn't really matter. I've been washing these stirrers in between trials, so we shouldn't have any cross-contamination. Next up, we're going to add 2 drops of this potassium ferrocyanide, and we should see some kind of a light green precipitate, which we may need to heat to see. See, it itself is kind of a light yellow-green color. Oops. 3 drops. So we can see our known has formed a precipitate. I don't know that it's light green, but our unknown has not. So let's go ahead and heat them in a water bath and see if the green color comes to life. So I'll put my solutions in this hot water bath and we'll see if this green comes to fruition. Try to move it around, that way we can get a good angle of it. Remove this thermometer, we don't really need that. Leave it there for 10 minutes. All right, so at this point you can see that our known has formed this green precipitate. And it's actually quite easy to see, so I guess it worked well this time. Our unknown does not, if you look closely, it doesn't have a precipitate in there, and it's certainly not green. It's turned a deep blue, but that's not the indication we're looking for. So, green precipitate, no green precipitate.